In 5 years, we won't measure AI intelligence by how many tokens it generates. We'll measure how deeply it thinks per token.
Wait, are you saying token count is becoming irrelevant for reasoning tasks? So, we're breaking down these deep thinking tokens, how to identify them, and what this means for scaling strategies?
By minute 4, you'll know exactly why think-at beats chain of thought every time. Let's get into it.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into Think Deep, Not Just Long, measuring LLM reasoning effort via deep thinking tokens.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about something that's fundamentally changing how we think about AI reasoning. There's this new research paper that just dropped, Think Deep, Not Just Long, and it's challenging everything we thought we knew about how large language models actually solve problems.
Oh, this is about that whole more tokens equals better reasoning assumption, right? I've been seeing a lot of debate about that lately.
Exactly. For years, we've been operating under this assumption that if an AI generates a longer response, it must be thinking harder or reasoning better. But this research from a team of academics is showing that's not just wrong, it's actually backwards in many cases.
Wait, so you're telling me that when GPT-4 or Claude gives me a wall of text, that doesn't necessarily mean it's doing better reasoning?
Not only that, sometimes those long responses are actually a sign of what they call overthinking. The AI is essentially spinning its wheels, generating more tokens without actually improving the quality of its reasoning. It's like watching someone pace around a room muttering to themselves versus someone sitting quietly and really thinking through a problem.
That's fascinating. So, how do they actually measure real reasoning effort then?
This is where it gets really interesting. They've identified something called deep thinking tokens. These are specific tokens where the model's internal predictions undergo significant revisions in the deeper layers before it settles on what to output.
So it's not about how much the model says, but how hard it's working internally on each token?
Exactly. Think of it like this. Imagine you're solving a complex math problem. The number of words you write on the page doesn't tell us how hard you're thinking. But if we could somehow measure how much your brain is revising and reconsidering each step before you write it down, that would be a much better indicator of actual reasoning effort.
And they tested this on some pretty serious benchmarks, right?
Oh yeah, we're talking AIM, that's the American Invitational Mathematics Examination, HMMT from Harvard MIT, and GPQA Diamond, which is graduate-level science questions. These aren't your typical what's 2 plus 2 problems. They tested this across multiple models too, GPT-OSS, DeepSeek R1, and Qwen 3.
Those are some heavy-duty reasoning tests. What did they find?
The correlation between their think-N ratio, that's the proportion of deep thinking tokens in a response, and accuracy was consistently positive across all benchmarks and models. Meanwhile, the correlation between response length and accuracy, sometimes positive, sometimes negative, totally unreliable.
This reminds me of what we saw with OpenAI's O1 model. They need such a big deal about giving the model more thinking time.
Absolutely. And this research helps explain why that approach works. It's not just about letting the model ramble on longer. It's about the quality of the reasoning happening under the hood. OpenAI was onto something, but they didn't necessarily explain the mechanism. This research gives us a way to actually measure and optimize for it.
But wait, if we need to analyze these deep thinking tokens, doesn't that add computational overhead? How practical is this for real-world applications?
That's the million-dollar question, and it's where their think-at-N strategy comes in. But before we dive into that, coming up, we'll dig into exactly how they pulled this off and what it means for the future of AI efficiency. Because here's the thing. They've figured out a way to actually reduce inference costs while improving accuracy. Stick with us.
All right, so walk me through this think-at-N strategy. How does measuring deep thinking tokens actually help us reduce costs?
So here's the clever part. Traditional approaches like self-consistency, where you generate multiple responses and pick the most common answer, they require you to generate complete responses every time. If you're generating 10 responses of 1,000 tokens each, that's 10,000 tokens of compute.
Right, and that gets expensive fast, especially with models like GPT-4 charging per token.
Exactly. But Think at N flips this on its head. Instead of generating complete responses and then evaluating them, it monitors the deep thinking ratio in real time as tokens are being generated. If a response starts with a low deep thinking ratio in its prefix, say the first 100 tokens, you can reject it early and move on.
Oh, so you're essentially doing quality control during generation rather than after.
Precisely. In their experiments, they found that samples with high deep thinking ratios in their prefixes were significantly more likely to produce correct answers. The correlation was strong enough that they could confidently reject low ratio samples early.
But how much does this actually save in practice? I mean, you still need to analyze those internal layer activations, right?
Great question. They tested this extensively, and the results are pretty compelling. On the AIME 2024 benchmark, ThinkAt achieved 76.7% accuracy, while traditional self-consistency got 73.3%. But here's the kicker. ThinkAt did this while evaluating 40% fewer total tokens on average.
Wait, better accuracy with less compute? That seems almost too good to be true.
I know, right? But when you think about it, it makes sense. They're essentially filtering out the overthinking responses early, the ones where the model's just generating tokens without real reasoning progress. It's like having a really good editor who can tell within the first paragraph whether an essay is going somewhere useful.
What about the technical implementation? How computationally expensive is it to calculate these deep thinking tokens?
So they measured the flipping rate, basically how much the model's predictions change between intermediate layers and the final layer. For each token position, they compute the KL divergence between predictions at different depths. Tokens with high flipping rates are classified as deep thinking tokens.
Ah, so you're looking at the internal decision-making process. If the model keeps changing its mind through the layers, that indicates deeper reasoning.
Exactly. And here's what's really interesting. They found that different types of problems have characteristic deep thinking patterns. Mathematical proofs tend to have bursts of deep thinking tokens around key logical steps. Scientific reasoning problems show more distributed patterns.
That actually makes intuitive sense. When I'm solving a math problem, there are definitely those aha moments where everything clicks.
Right? And the models seem to exhibit similar patterns. They also found that confidence-based metrics, looking at the model's output probabilities, were much less reliable indicators of reasoning quality.
But here's what I'm wondering. Doesn't this approach favor certain types of reasoning over others? What if some problems genuinely require more exploratory thinking?
That's a really astute observation. They did find variations across problem types. For instance, on the GPQA Diamond dataset, those graduate-level science questions, the deep thinking patterns were more complex and distributed compared to the more structured math problems.
So would you need to tune the thresholds differently for different domains?
Most likely, yes. They used a threshold of 0.1 for the flipping rate to classify deep thinking tokens, but that might need adjustment based on your use case. The good news is that the correlation between deep thinking ratio and accuracy held across all domains they tested, even if the absolute values varied.
What about model architecture? Does this work across different types of models?
They tested it on quite different architectures. GPT-OSS uses a standard transformer design, DeepSeek R1 has some unique optimizations, and QN3 has its own architectural tweaks. The deep thinking patterns showed up consistently across all of them, though the specific ratios varied.
That's encouraging for practical adoption. You wouldn't want something that only works on one specific model.
And get this, they even found that you could train a lightweight classifier to predict final answer correctness based on just the deep thinking patterns in the first 10 to 20% of the response. The accuracy of these predictions was remarkably high.
So you could potentially build this into production systems as a real-time quality filter.
Exactly. Imagine having an AI assistant that knows when it's reasoning well versus when it's just generating fluff. It could even tell you, hey, I'm not confident in this reasoning. Let me try a different approach. Stick around. In our final segment, we'll give you the exact checklist for implementing this in your own systems and what this means for the future of AI development.
All right, so let's get practical here. If I'm running AI systems in production, how do I actually implement this deep thinking approach?
First, let's talk about the immediate actionable steps. If you're using commercial APIs like OpenAI or Anthropic, you can't directly access the internal layer activations needed to calculate deep thinking tokens, but you can start applying the principle in other ways.
Like what?
Well, you can implement a version of early stopping based on response coherence, monitor the first 100 to 200 tokens of a response. If it's meandering or repetitive, cut it off and regenerate. You won't get the exact deep thinking metrics, but you can approximate the benefit.
So it's like building a quality heuristic based on the observable output patterns.
Exactly. And here's another approach. For critical reasoning tasks, explicitly prompt the model to show its work, but be concise. Something like, solve this step by step, but only include steps where you're making meaningful progress. You're essentially asking the model to self-filter for deep thinking.
What about for teams running open source models?
Oh, this is where it gets really interesting. If you're running models like Llama or Mistral locally, you can actually implement the full deep thinking token analysis. You'll need to modify your inference pipeline to capture intermediate layer activations, but the paper provides the algorithms.
That sounds like it could add latency, though.
Initially, yes. But remember, the goal is to reduce total compute by rejecting bad reasoning paths early. The paper shows that even with the overhead of computing flipping rates, you end up saving 30 to 40% on total inference cost for complex reasoning tasks.
What kinds of applications would benefit most from this?
Think about any scenario where reasoning quality matters more than speed. Code generation, mathematical problem solving, scientific research assistance, legal document analysis. These are all areas where you'd rather wait an extra second for high-quality reasoning than get a fast but potentially flawed response.
What about conversational AI or customer service bots?
That's where you'd need to be more selective. For simple FAQ-style responses, this overhead isn't worth it. But for complex troubleshooting or technical support, where the AI needs to reason through multiple possibilities, absolutely worth implementing.
Looking ahead, how do you see this changing AI development?
I think we're seeing a fundamental shift in how we'll build and evaluate AI systems. Instead of just scaling up model size or training data, we'll focus on reasoning efficiency. This could democratize access to advanced AI capabilities.
How so?
Well, if you can get GPT-4 level reasoning quality by running a smaller model more efficiently, suddenly advanced AI becomes accessible to startups and researchers who can't afford massive compute budgets. It's not about having the biggest model anymore. It's about using what you have most effectively.
That's a game changer for the industry. What should teams be watching for in the next 6 to 12 months?
First, I expect we'll see major AI providers starting to expose reasoning quality metrics in their APIs. OpenAI is already moving this direction with their O1 models' thinking tokens. Second, watch for new benchmarks that measure reasoning efficiency, not just accuracy.
Any specific technical trends to track?
Definitely keep an eye on research around reasoning distillation, training smaller models to replicate the deep thinking patterns of larger ones. Also, hardware optimizations specifically for this kind of multi-layer analysis. NVIDIA and others are already working on inference accelerators that could make deep thinking token analysis nearly free.
What's the biggest misconception you think people have about this?
That this is just about making AI faster or cheaper. It's really about making AI reasoning more transparent and controllable. When we can measure and optimize reasoning quality, we can build AI systems that know their limitations and can communicate uncertainty more effectively.
That's huge for AI safety and reliability.
Absolutely. Imagine an AI that can tell you, I'm only showing 20% deep thinking tokens on this response, so take my answer with a grain of salt. That kind of self-awareness could prevent a lot of AI mishaps.
So, final thoughts. What's the one thing listeners should do this week?
If you're using AI for any critical reasoning tasks, start logging response patterns and correlating them with accuracy. Even without fancy deep thinking metrics, you'll start to see patterns. Which responses tend to be correct? Which ones tend to fail? Build your own heuristics based on your specific use case.
And maybe start pushing your AI vendors to provide more transparency about reasoning quality.
Exactly. The more demand there is for reasoning transparency, the faster we'll see these capabilities in commercial offerings. We're at an inflection point where AI is moving from impressive parlor trick to reliable reasoning partner. And metrics like deep thinking tokens are key to that transition.
This has been a fascinating deep dive. The idea that we can actually measure and optimize how AI thinks, not just what it produces, really does feel like a paradigm shift.
It really is. And here's my closing thought. We're moving from an era of AI as a black box to AI as a glass box. The ability to see and measure reasoning effort doesn't just make AI more efficient, it makes it more trustworthy. And in a world where AI is making increasingly important decisions, that transparency isn't just nice to have, it's essential. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development with Anthropic's Claude that's really ruffling feathers in the developer community. According to the Register, Anthropic just pushed an update to Claude code that hides file access information during code generation.
Wait, they're hiding what files Claude is accessing? That sounds like a nightmare for debugging.
Exactly. Developers are up in arms about this. They're saying it makes it nearly impossible to track security issues or debug problems when they can't see what Claude is actually touching in their codebase.
I can see why they'd hate that. Transparency is crucial when you're letting AI touch your code.
Speaking of AI development practices, Martin Fowler's site just published a really insightful piece on harness engineering. It's based on OpenAI's recent work and talks about how context engineering is becoming this critical skill.
Harness engineering? That's a new term for me.
It's essentially about building the right frameworks and contexts around AI systems to make them more effective in software development. The article emphasizes that it's not just about the AI model itself, but the entire ecosystem you build around it.
Anthropic is making some big moves globally. They just signed an MOU with the government of Rwanda to integrate AI into education, health, and public sector systems.
That's right. Anthropic announced this partnership is focusing on accelerating AI adoption across Rwanda's key sectors. It's interesting to see AI companies partnering directly with governments like this.
Definitely a trend to watch. And speaking of global AI initiatives, Cohere just dropped something pretty impressive.
Oh, yes. TechCrunch reports they've launched Tiny Aya, a whole family of open-weight multilingual models that support over 70 languages. The kicker? These models are designed to run on everyday devices.
That's huge for developers building multilingual applications. Having models that can run locally on regular hardware instead of requiring cloud infrastructure could be a game changer.
Absolutely. It really democratizes access to multilingual AI capabilities.
That wraps up today's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.